Hello, and thanks for mathing with me today. In this video, we're going to solve multi-step equations. In the previous video, we learned how to solve one-step equations. In the same way we used inverse operations to solve one-step equations, we are going to use these same inverse operations with our properties of equality to solve multi-step equations. The first step in solving multi-step equations is to use the inverse operations to isolate the term that contains the variable. Once you do that, then you're going to also isolate the variable, and then lastly write your answer in set notation. Let's try some examples. In the first example, it says -2 equals -1 plus x over 9. So the first thing we want to do is identify that this is the term that contains the variable. So this is the term that I want to get by itself, which means that I want to get rid of this -1, right? We have x over 9 minus 1, basically. So to undo -1, we want to add 1 to both sides. So on the left, we have -2 plus 1, which is -1, equals, and then our -1 plus 1 adds to 0, so all we're left with on the right is x over 9, which is what we wanted. So now that we have isolated the term that contains the variable, we want to use the inverse operation to isolate the variable itself. So I have x over 9. -1 equals x over 9, or x divided by 9. So we want to think about the inverse operation that will get rid of divide by 9, and that is to multiply by 9. So we want to multiply both sides by 9. So I'm going to put parentheses around my negative. And then we want to simplify both sides. So we have 9 times -1 on the left, which gives us -9. And on the right, we have x divided by 9 multiplied by 9. So we just have x. So our answer is x equals -9. And then we want to put that in set notation. And that is our final answer. Let's try another one together. Number 2, we have -6x plus 3 equals -51. So again, let's identify that this is the term, -6x, that contains the variable that we want to isolate. So we want to get rid of the plus 3. How do we get rid of plus 3? We subtract 3. So we're going to subtract 3 from both sides. And remember that once you get used to doing these operations, you don't necessarily have to write the things that I'm writing in pink. So you can just perform the operations and simplify the sides without writing them. So the things that you're writing in purple are really the necessary steps to write in order to show all your work. It helps when you're first learning to solve equations to write these steps that are in pink. All right, so now that we have isolated the term that contains the variable, so -6x, we want to isolate x itself. So what is happening? We want to think about what operation is happening. We are multiplying -6 times x, which means to undo that, we want to divide by -6. So we're going to divide by -6 on both sides. On the left, we get -6x divided by -6, right? Those two things undo each other, so they divide to be 1. So we're left with 1x, but we don't write 1x, we just write x. And then -54 divided by -6 is going to give us a +9. So we have solved x equals +9, and I always like to box our final answer after we write it in set notation. Let's try one more example together, and this example is in a little bit different format because we have on the left -4 equals, and then we have -2 plus m all divided by 4. So the order that we do things is going to be a little bit different here because both terms on the right are being divided by 4, so we have to undo that division first. So the first step in this example is we're going to multiply both sides by 4. When we do that, on the left, we get 4 times -4, which equals -16. And then on the right, these two things undo each other, which leaves us with -2 plus m, or m minus 2, same thing. The next step is just to isolate the variable. So we have m minus 2 on the right. To get rid of -2, we want to add 2 to both sides. On the left, we have negative 16 plus 2, which equals negative 14. And on the right, we have m minus 2 plus 2, so that leaves us with m. So m equals negative 14. All right, now it's your turn to try. So try examples 4 and 5 on your own. So pause the video and try those examples on your own. All right, hopefully you paused the video and solved these on your own and got for number 4, negative 8, and number 5, v equals 11. Notice that it doesn't matter which side the variable is on. So sometimes the variable is on the left side, sometimes it's on the right side, and you'll even run into situations where the variable might be on both sides, right? But always the goal is to get the variable by itself on one side and then to use inverse operations to find what equals the variable on the other side. Let's try one more example. Pause the video and try number 6 on your own. Hopefully you paused the video and found that p equals negative 19. Let's try some examples with a little different format. In these cases, you need to distribute and combine like terms and then solve. In one of my previous videos, I talked about how to distribute. So hopefully you remember that you multiply that term that's in front of the parentheses by each of the terms in the parentheses. So we have 5 times x equals 5x, and then we have 5 times 4 is going to give us a plus 20, and then that is equal to 40. Now we're doing what we did in the previous example. We want to isolate 5x first, and I'm going to do this without showing those steps in pink just to show you what the work looks like when you don't do that. So in my head, I know that I'm subtracting 20 from both sides. That leaves me with 5x on the left, and then on the right, I think to myself, 40 minus 20, and that's going to give me 20. Then the next step, I have 5 times x on the left, and I want to get x by itself. So to do that, I'm going to divide by 5, right? I'm multiplying by 5. To undo multiply by 5, I divide by 5, and I'm also going to do that in my head. I know that 5x divided by 5 is going to leave me with x, and then 20 divided by 5 is equal to 4. So in this way, I'm not showing all of those steps that I showed in the previous examples, but I'm doing all of that same work that I showed in the steps in pink. I'm doing it in my head. So let's try that again with number 8. So in number 8, we have 15 minus the quantity 4m minus 5 equals 32. In this example, we're distributing the negative, and you can almost think of it as you're multiplying by -1 by each of those terms. So the 15 is just itself, and I'm subtracting 4m minus 5. So I'm subtracting 4m, and then I'm subtracting -5. So subtracting -5 means a plus 5, and that's equal to 32. On the left, the first thing I'm going to do is combine like terms, right? I see that I have 15 and I have a plus 5. Those two are like terms. So 15 plus 5 is 20. That gives me negative 4m plus 20 equals 32. And then I want to subtract 20 from both sides. So that gives me negative 4m. 32 minus 20 is 12. And then I want to isolate m, so I'm going to divide both sides by -4. -4m divided by -4 gives me m on the left, and 12 divided by -4 gives me -3 on the right. So our solution to number 8 is -3. One more example together. We have 2 times the quantity 5 minus 3v plus 9v equals 28. So the first step here is to distribute. 2 times 5 gives me 10. And then 2 times -3v is going to be a minus 6v. And we have a plus 9v equals 28. So on the left, I see that I have a negative 6v and a plus 9v. Let's combine like terms there. So that gives me 3v. I like to write my variable first, but it doesn't matter. You could have put 10 plus 3v or 3v plus 10 on the left equals 28. I see that the next step to isolate my term that contains the variable is to subtract 10. So minus 10 on the left leaves me with a 3v, and minus 10 on the right gives me 18. And then I want to divide by 3. That leaves me with v on the left, and then 18 divided by 3 is 6. So we get v equals 6 as our solution. All right, next up, some examples for you to try on your own. Pause the video and try numbers 10 and 11. Hopefully you paused the video and you were able to distribute and combine like terms and then solve for w, which equals 1 in number 10, and for t, which equals -2 in number 11. Let's try number 12 on your own. Pause the video and try number 12. All right, hopefully you paused the video and found that u equals -4. There are some special cases that we want to consider. So let's solve these and talk about the special cases that might occur. So on the left, we have 2x plus 3, and we're going to leave that. There's nothing we can do with that in the first step, because on the right, we want to distribute the 2. So we get 2 times x equals 2x, and 2 times 5 equals plus 10. So in this situation, when you have variables on both sides of the equation, we want to move the variables so that they are on one side or the other. So I want to subtract 2x from both sides to move the 2x to the left side. So if I subtract 2x from both sides, what I'm left with is 3 equals 10, right? The variables undo each other, right? We get 0 plus 3 on the left and 0 plus 10 on the right, which leaves us with an equation 3 equals 10, which we know is not true, right? 3 does not equal 10. If this situation occurs, it means that there is no real solution. And when we write no real solution in set notation, it is just the empty set. It means that there's no solution that satisfies this equation. There's no solution, there's no value of x that will make this equation true. So anytime you get this situation where the variable goes away and the equation that you are left with is not true, the answer is no real solution, or the empty set. In number 14, let's see what happens. So in number 14, we have -5x plus 10 on the right. We're not going to do anything with that in this step. On the right, we need to distribute again. So we have -5 times x gives me -5x, and -5 minus 2 gives me a plus 10. In this situation, we want to move our 5x, right? Our -5x from the left or from the right side. I want to add 5x to both sides so that I can move it to the left side. When I do that, I get 0x again. So I get an equation again that has no variable. In this case, though, our equation says 10 equals 10. So the variable goes away, but the equation that we're left with is true. So that means that no matter what value, any real number value that I plug in for x, is going to make this equation true. So in this case, the answer is all real numbers. And we can write ARN to stand for all real numbers. And then there's another symbol that some people like to write that looks like this. So either any 3 of these would be a satisfactory answer to this type of equation. It is my hope that in this video you learned how to solve multi-step equations. Thanks so much for mathing with me today.